All right, friends, welcome back to part 3. Here we go. We're going to bring it home. Let's start with number 22. All right, so a parking lot has a perimeter of 500 feet. The width is 20 feet less than the length. Find the dimensions, okay? This is one of those things where I'm going to ask you to remember some stuff about geometry. So first thing I would recommend is drawing the parking lot, all right? A parking lot generally is going to be a rectangle, okay? A rectangle. And we know that perimeter is the distance all the way around the parking lot. All right, so that distance, so perimeter, is 500 feet. How do we find perimeter? Well, we add up the distance around. So if we know that the width is 20 feet less than the length, we don't know what either of those are, but if we're comparing the width to the length, we can say that the length is going to be x units long. All right, and then if the width is 20 feet less than the length, so it's going to be 20 feet less than whatever our length is. So this is going to be x minus 20. All right. And then we also know that this, since it's a rectangle, this is going to be x units long, and this is going to be x minus 20 units long. So our perimeter is equal to 2 times the width plus 2 times the length, which generally is an L, 2 times the length. Or we can just do width plus length plus length. From there, perimeter is going to be equal to 2 times our width, which is x minus 20, and then plus 2 times x. So perimeter equals 2x minus 40 plus 2x. All right. So our goal is to find the dimensions. If we know that the total perimeter is 500 feet, we can replace p with 500. Okay. Perimeter is 500 feet, so we add our two x's together, so we get 500 equals 4x minus 40. Add 40 to both sides, we get that 500 equals, or excuse me, 540 when we add 40 to both sides is equal to 4x. Divide both sides by 4, we get, let's see, 5 divided by 4 gives us 1, 14, that is 3, and then 20. So 135 is equal to x. So our length, right? So width is 20 feet less than length. Yes, width is 20 feet less than length. Our length is 135 feet. Our width is our length minus 20, which is going to be 135 minus 20, which is 115 feet. So our width is 115 feet. So if you take 135, multiply it by 2, plus 115 times 2, you should get 500 feet. On to the next problem. Let's go. All right, so this is asking us to simplify in terms of I. So if we have the square root of negative 13, excuse me, whenever we have a square root of a negative number, we need to say, okay, 13, split it up into negative 1, or excuse me, negative 13 splits up into negative 1 and 13. 13, however, is a prime number, so we can't take that out, but this turns into an I. So we have I times the square root of negative 13, or square root of not negative 13, I times the square root of 13, or square root of 13 times I. One of these two, whichever you prefer. If you decide to use this one, please make sure that there is a noticeable gap between your square root and your I. I want to make sure that you are not putting the I underneath the square root. Okay? So, on to the next problem. 24. All right, we have negative square root negative 121. All right, so this negative is just going to be along for the ride. This guy right here just comes along for the ride. We have to deal with the stuff under the radical. Okay, so we make a factor tree. Negative 121 splits up into negative 1 and 121. 121 doesn't divide by 2, doesn't divide by 3, doesn't divide by 5, doesn't divide by 7, doesn't divide by 9, but it does nicely divide by 11. And as a matter of fact, we get 11 and 11. So this guy, this becomes I, And then we have a team of 11s to make it out. And there's nothing anywhere else, no other terms that weren't able to make it out from underneath the radical. So we pull out the 11, we pull out the I, and there's nothing underneath the radical. So it's negative 11I. That is our answer. Okay? Make a factor tree. They are your friend. On to 25. Here we have a complex number subtracted from another complex number. So 5 minus 3i minus, 3i minus 6 plus 2i. So here we subtract the real parts and then we subtract the imaginary parts. So 5 minus 6 leaves us with negative 1. Negative 3i minus a positive 2i is going to take us 2 more to the negative, so it's going to be negative 5i. Okay? So that is how we would do this. Combine the real parts, combine the imaginary parts, and then you have your answer, your new complex number. On to the next problem. I'm getting bored with red, so I'm switching over to green. Here we have a multiplication problem. Things get a little bit different when we're multiplying. So just like we would with any kind of variable stuff, in order to deal with this, we have to distribute. All right, so 7 times 4 gives us 28. 7 times negative 3i is negative 21i. 6i times 4 is going to be plus 24i. And then 6i times negative 3i is going to be negative 18i squared. Okay? Before we start combining like terms, I want you to remember that I squared equals negative 1, because I is equal to the square root of negative 1. I is equal to the square root of negative 1. And then, so if we square I to get to I squared, if we square I to get to I squared, that's going to be the square root of negative 1 squared. And when you square a square root, they cancel each other out, and we're left with just negative 1. So this guy right here ends up being negative 18 times negative 1, which is going to be just good old positive 18. Okay, so let's rewrite this. 28 minus 21i plus 24i plus 18. Now we want to combine like terms, and remember, whenever we have a complex number, whenever we have a complex number answer, we always want it to be of the form a plus bi, where a and b are real numbers. So we add together our real numbers, 28 and 18. We're looking at, let's see, 36 and 10 is 46. And then negative 21 plus negative 21 i's plus 24 i's is going to leave us with positive 3 i's. And there is our solution for our complex number. There's our complex number solution, excuse me. On to the next problem. Let's go. So here we have division. In order to divide 3 minus 2i over 7 plus I, in order to divide, we need to multiply the top and the bottom by the complex conjugate of the bottom. The complex conjugate is identical to the number itself, except for this term right here in the middle, or excuse me, the sign in the middle, it changes. So the complex conjugate of 7 plus I is 7 minus I. And the complex conjugate of the top is, or excuse me, we multiply the top and bottom by that 7 minus I. Okay? So the reason that we use that complex conjugate is because it makes our denominator nice. The shortcut that we can use when we're multiplying complex conjugates, you feel free to distribute them if you want, but the shortcut that we can use is is this guy squared plus the term in front of I squared. If we add those two together, that will give us our new number after we multiply those complex conjugates together. So 7 squared is 49. 1 squared is 1. So 49 plus 1 is 50. Okay? So now we need to distribute across the top. 3 times 7 is 21. 3 times negative I is negative 3i. Negative 2i times 7 is negative 14i. And then negative 2i times negative I is positive 2i squared. Remember, I squared is equal to negative 1, so we're going to make that go away, and then this sign changes. So then we're left with 21 minus 2, which is 19. And then negative 3 minus 14 is negative 17i over 50. We're close, but we're not quite there. Remember, we always want to have a plus bi for all of our solutions. So we can split this fraction up into 19 over 50 minus 17i over 50, over 50. And then we can take this I and move him outside of our fraction. 19 over 50 minus 17 over 50i. And there is our solution, a plus bi. All right? So there is our solution for that. All right? On to the next problem. So when you have I to some massive exponents, remember, we are going to take the exponent and divide that thing by 4. All right? We'll get some number up here, and then we'll have a remainder. Remainder is going to be from 0 through 3. All right? So if we have remainder 1, that I value is going to be effectively 1 times I to the first, or it's just going to be I. All right, let's start with remainder 0. If we have remainder 0, that means that we had a bunch of groups of I to the fourth, which we talked about in class was just the number 1. So if we have a remainder of 0, then we had a bunch of just number 1s. So this is going to be remainder 0 is 1. Remainder 1 means that we're going to have I. Remainder 2 means that we're going to have negative 1. Remainder 3 means that we are going to have a negative I. And then it keeps recycling. It keeps going back in this same pattern. 1i, negative 1, negative I. 1i, negative 1, negative I. So if we take 18 and divide that by 4, we know that 4 is going to go into 18 4 times, which is going to give us 16. Subtract, we're going to get remainder 2. Since we have remainder 2, we are looking right here. So I to the 18th power is going to be negative 1. Okay? That is what I to the 18th power is equal to. All right? Cool. On to the next problem. All right. So for this one, you were asked to find the zeros of the function. So the zeros of the function are found when f of x is equal to 0. Okay? When our y value is equal to 0. 0 equals 3x plus 1. We're just solving this thing to find out what value of x makes our graph 0. So we want to get x by itself. We subtract 1 from both sides, equals 3x, and then divide both sides by 3, we get negative 1/3 equals x. And that is our solution. That's the solution to that particular equation. That is the value of x that gives us a 0. Okay, on to the next one. So here we have another problem. Again, we're looking for where f of x is equal to 0. That's finding the 0 of the function. Equals 3x squared plus 25x. 3x squared plus 25x minus 18. All right, so again, we want to check and see, can we get x squared equal to some number? In this case, we can't. We can't do that because of this x right here. Okay, so that x right there keeps us from being able to get x squared equals some number. Second, can we factor it? Can we factor it? Let's try. Let's find out. So, since this number right here is not 1, we need to multiply a times c. So 3 times negative 18 is negative, let's see, 3 times 18, so that's 30 plus 24, so that's negative 54. So we need two numbers that multiply to be negative 54 that add to be 25. So let's start dividing. Negative 1, positive 54, negative 2, and let's see, I think that's 27. Yep, 27. Let's see, does 3 work? 3 does. Negative 3, and that goes, let's see, that's 1, and 3 and 18. Duh, I just multiplied those two together. Wow. All right, 3 and negative 18. Let's see, let's keep going. Does 4 work? 4 does not. 5 does not. 6 does. So negative 6 and positive 9. 7 does not work. 8 also does not work. So then we also have negative 9, positive 6, negative 18, positive 3, negative 27, positive 2, and negative 54, positive 1. We start adding these up. We're hoping to add to 25. Can we add to 25? Negative 1 and 54 is 53. That doesn't work. Negative 2 and 27, Yahtzee. We found it. So, negative 2 and 27. Once we found these, now we need to split this guy up into those two factors. So, we have 0 equals 3x squared minus 2x plus 27x minus 18. If you take and look at negative 2x plus 27x, you get back to 25x. Okay? So, now we're going to ask, what do these first two terms have in common? What do these two terms have in common? They have an x squared. And then we're left with 3x minus 2. Nope, they just have an x, not an x squared. My bad. They have 3x minus 2 is left over. And then these two terms have a 9 in common, it looks like. So we can factor out a 9, and we're left with, let's see, that would be 3x minus 2. So now, these two terms had a 9 in common. So this term has, in common with this term, a 3x minus 2. 3x minus 2 times, the thing that's left over when we take out 3x minus 2 from both of them is x plus 9. And remember, all these things, they all equal 0. So if I have something times something else, and it equals 0, one of those two things has to be 0. We're not sure which one because they both have x's, so we have to figure out what values of x make both of these 0. So we have 3x minus 2 equals 0, and we also have x plus 9 equals 0. Solving these guys for x, we get that 3x is equal to 2, x is equal to 2/3. Subtracting 9 from both sides, we also get that x is equal to negative 9. And we have our zeros. We have the values of x where our graph is going to cross the x-axis. Okay? So because we were able to factor, we didn't have to use completing the square, or we also didn't have to use the quadratic formula. FORM means quad form. We didn't have to use either of those because we could factor, and it saved us a lot of time being able to do that. Okay, on to the next problem. All right, this guy, we want to find the zeros for. We want to find the zeros for it, so f of x equals 0. And when f of x equals 0, we want to find what is going to make our x values, what values of x are going to make that a true statement. So first we want to see, can we get x squared to be equal to some number? This x right here keeps us from being able to do that, so we can't use that. Can we factor? 2. Can we factor? Can we factor? I promise, that word says factor. All right, so we're looking for two numbers that multiply. Since we don't have any number in front of x, we don't need to worry about multiplying beforehand. Do we have two numbers that multiply to be negative 15 that add to be that add to be 6? All right, so we have, let's see, negative 1 and 15, negative 3 and 5, negative 5 and 3, and then negative 15 and 1. So if we add these two together, we get 14. Here we get 2. Here we get negative 2. And here we get negative 14. None of those add up to be 6. So we have to do a couple other things. We have to either use completing the square, or we have to use the quadratic formula. Okay. I'll actually work through this both ways. I'll actually show you both ways that this is going to happen. Okay. So for completing the square, we always want to have, I'll do completing the square in red. Whoop. Get up there. So completing the square will be in red. In order to complete the square, we need to have our equation. We want to get our equation into x squared plus bx equals c. We want to get the x terms on one side, the numbers on the other side. So the way we're going to do that is we're going to add 15 to both sides. So we're going to get x squared plus 6x equals 15. That's how we added 15 to both sides of the equation. Okay? X squared plus 6x equals 15. So then we have to find the completing the square value. The way we do that is by taking b over 2 and then squaring that number. Okay? In this case, b is 6, so 6 divided by 2, and we square that, we get 3 squared, which is 9. This is our completing the square value. Completing the square value. Okay? We are going to take that completing the square value and we're going to add it to both sides of our equation to keep our equation balanced. X squared plus 6x plus 9 equals 15 plus 9. So by completing the square, we have forced this to be a perfect square trinomial. So when we factor it, it's always going to be of the form x, and then whatever sign this is going to go right into our parentheses, plus, and then the number that we squared, so this guy right here, 3, that is going to be our second half. The number that we squared is going to be the second part of our parentheses, and that is going to be squared. 15 plus 9 is going to be 24. So then, our goal is to get x by itself, so we're going to take the square root of both sides, so we get x plus 3, because a square root undoes a square, equals plus or minus square root 24. So from here, we're going to take 24 and make a factor tree for it. So 24 factors to 2 and 12, which then factors to 2 and 6, which then factors to 2 and 3. Okay? So we need teams of 2 to escape our radical. So here are 2 2's, but these other 2 guys don't have enough friends to escape. Whoopsie, come back. These other two guys do not have enough friends to escape the radical prison. So we get x plus 3 equals plus or minus 2 from these guys. This is from the team that made it out from these guys, times the square root of 2 times 3 is 6. Okay? We want to get x by itself, so we're going to subtract 3 from both sides. We're going to get that x is equal to negative 3 plus or minus 2 times the square root of 6. And that is our solution by completing the square. So now, let's solve this guy by quadratic formula. All right? So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. And then that whole value is then divided by 2 times whatever a is. So in this equation, we have that x is equal to, b is 6, so negative 6 plus or minus the square root of 6 squared minus 4 times a is 1 and c is negative 15. And that whole thing is divided by 2 times a, which is 1. All right, so if you want, it might be nice, it might help you to make a list. A equals 1, b equals 6, c equals negative 15. If that helps, make a list, all right, to help you fill in your values into the correct spots. So here we have, let's start expanding some of these. So x is equal to negative 6 plus or minus the square root of 6 squared is 36. And then negative 4 times 1 is negative 4. Then times 15 is positive 60. So plus 60. That whole thing is divided by 2. Okay? So then from here, we want to continue working with this radical. So x equals negative 6 plus or minus the square root. 36 plus 60 is 96. And that whole thing is divided by 2 still. All right, so let's take a look at 96. If we make a factor tree for that, we divide it by 2, and then we get, let's see, 96, that is 42 and 48. which then gives us 2 and 24, which then gives us 2 and 12, 2 and 6, 2 and 3. Now we're looking for teams of two things, 2 and 2, 2 and 2, and then these guys, they don't have enough friends to make it out of the prison. So we have x equals -6 plus or minus. We have a 2 here, so 2 times a 2 here, 2 times the square root of 6, all over 2. All right, I'm going to scroll up a little bit. So we have x equals -6 plus or minus 4 times the square root of 6 over 2. But we always want to make sure to reduce all of our fractions. So if we split this up into two equations, or into two fractions, we have -6 over 2 plus or minus 4 times the square root of 6 over 2, which is then going to say, all right, x equals -6 over 2. -6 over 2 is -3 plus or minus 4 divided by 2 is 2 times the square root of 6. We have this guy, and hey look, they are identical. So whichever path you decide to use, whichever path you want to use, unless I explicitly say solve by completing the square or complete the square, use either direction. Doesn't matter to me as long as you are getting to an answer. Okay? Use your favorite. All right, on to the next problem. All right, so we have a graph, we have a function, f of x equals x squared minus 6x plus 4. First, we need to find the vertex, but in order to find the vertex, we need to find the line of symmetry. Then we can state whether there is a maximum or minimum value. Then we want to find that value, find the range of the function, graph that function. Okay, so those are the things that we need to do. So let's go to work doing this stuff. Again, I'm always going to say find the axis of symmetry first, so we're going to do step B first. So to find the axis of symmetry, when you have a standard form quadratic, that axis of symmetry is always going to be at the point, or at the line, -b over 2a. All right, in this case, our b is -6, so for us that's going to be +6 over 2 times a, which is 1, so 2 times 1. So we have 6 over 2, which is going to be 3. 3 equals x is our axis of symmetry. So for part B, 3 equals x is our axis of symmetry. So now that we have the axis of symmetry, we can go ahead and use that to find the vertex. So let's go circle back to part A. I'm going to ask you to do this stuff in the correct order tomorrow, so don't worry about that. So once we have our vertex, we can then plug it in to our function. We can plug it into our function to find our vertex. So f of 3 is going to be 3 squared minus 6 times 3 plus 4. So then we have, this is going to be equal to 9 minus 18 plus 4. So 9 minus 18 is -9, plus 4 is -5. So that's the y component of our vertex. So our vertex, so this is our axis of symmetry. Axis of symmetry. Our vertex is going to be, it's a point, and we take the x component from our axis of symmetry. X component from our axis of symmetry, in this case it's 3, and then the value that we get from our function when we plug 3 into our function. So in this case we got -5. So this is our vertex. Okay. So then for part C, we need to state whether it's a maximum, whether there is a maximum or a minimum value. Is this vertex the top or the bottom of the graph? All right. So if A is positive, then the vertex is a minimum. If A is negative, vertex is a maximum. In this case, we have 1 in front of our x squared, so this is a maximum. That's such a lie. There's a 1 in front of our x squared, so I literally just got done writing out that this thing is going to be a minimum. Okay, so for part C, we have a minimum for this graph. So then for part D, part C2, so the minimum value is y equals -5. Y equals -5 is our minimum value. All right, so that does it for part C. Part D, since it is a minimum, we're looking, our vertex is the bottom of the graph. All of the rest of the y's for that graph are all above that. Since since the vertex is at the bottom, -5 is the bottom of our graph. So all the rest of the y's are above it. So since all the rest of the y's are above it, y is greater than or equal to -5 for this particular graph. Okay, that is our range. Okay, that's our range for this graph. So then for part E, we want to graph the function. So for part E, we want to graph the function. So first we need to make a table, x and y. Always make a table for a function. I'm going to expect you to make a table for the function, so please do. We always want to start our table with our vertex, 3, -5. So we have the point 3, -5. There we have a point right there. So then we want to take steps in both directions. So we want a couple that are smaller to the left and a couple that are larger to the right. So some that are smaller would be something like 2 and 1, and some that are larger would be 4 and 5. So we're then going to take all those values and plug them into our function and get values. So 2 squared is 4 minus 12 plus 4. 4 minus 12 plus 4 is 8 plus -12, right? 8 plus -12, so this is going to be -4. So we get the point -2, -4. Okay? Since we took one step to the left and got -4, if we take one step to the right and go to 4, if we plug in 4, we're going to get 16 minus 24 plus 4. So 16 minus 24 is -8. Plus 4 is -4 again. Notice how this guy right here and this guy right here are the same. It's not a coincidence, okay? Because it is symmetrical. So if we take one step to the left, it's the same as taking one step to the right. So then if we plug in 1, we get 1 squared, so which is 1. So we plug in 1, we get 1 minus 6 plus 4. So 1 minus 6 is -5 plus 4 is -1. -1. So we get, let's see, 1, -1. And if you want, you can also continue taking steps out and continue getting additional x values, additional x points to make your graph that much more accurate. So you're going to, once you have your points, connect the dots to make a pretty parabola. Okay? And that's all there is to graphing. All right? So that is graphing beginning to end. So I'll have a problem where I'm going to ask you to do all those things. So please be prepared for that. So we will move on to the next problem. A homeowner wants to fence a rectangular garden using 60 feet of fencing. An existing stone wall will be used as one side of the rectangle. Find the dimensions for which the area is a maximum. We didn't talk too much about maximums and minimums, so I'm not going to actually have this on your test tomorrow. But it's an interesting problem, so I want you to understand how to do it. So we have a wall, okay, and we want a rectangular garden. Okay, here's part of the fence, part of the fence, part of the fence. Okay, so if we take this entire distance, this is 60 feet of fence. Okay, so if we look at each of these bends has got to be some length back, but they're both the same, so they're both x's. All right, and then so this length right here, sort of the front of the fence, is going to be 60 minus 2x, because we have the entire length of the fence minus these two bends back here. Okay, So it's 60 minus 2x. To find the area, area equals length times width. We want our area to be maximized. So we're going to take our length, which is 60, minus 2x. We're going to multiply it by our width, which is x. So our area equation is going to be 60x minus 2x squared, and we want to maximize that. So to maximize that, to figure out what that maximum x value is, what that x value needs to be for its maximum, if we think about this, since this is negative here, this equation, since this is negative on the x squared term, so this is actually a right here, and this is b, and c is 0. Since this is negative, we're going to have a maximum. So our area graph looks something like this. So the value that makes our area graph the biggest, the farthest away from 0, is going to be the x value, the vertex. So again, we do that. To find that, we say b over 2 times a, which could be negative b over 2a. In this case, it's going to be negative 60 over 2 times negative 2, which is going to be negative 60 over 4, over negative 4, which is going to be positive 15. So this bend right here, or the width, or the length, sure, let's go to the length. Length is equal to 15. So then the width right here is equal to 60 minus 2 times our length, which is 15. So 60 minus 30 is 30. So our width is 30, our length is 15. And those are the dimensions of our fenced-in area. Okay? So we can use this to solve real-world type problems. So we want to have as big a garden as possible. So we want to make sure that we are able to find that and able to use this sort of stuff to help us find our maximums and minimums. Okay? On to the next problem. Find a such that f of x equals ax squared plus 5x plus 6 has a minimum value of 7 over 7 and 1/24. Okay? So the way that we're going to work with this is we need to first find our midpoint. Our midpoint is negative b over 2a. Our minimum is going to be at our vertex. So negative b over 2a in this case is going to be negative 5 over 2 times a, whatever a ends up being. Okay? So this is going to be our x value that is going to give us our minimum. So we would then plug this in for x into our equation. So let's do that. We're going to plug in f of negative 5 over 2 times a. So in this case, we then are going to say, all right, equals a times negative 5 over 2a squared plus 5x plus 6. Oh, not 5x, my bad. 5 times, let's see, negative 5 over 2a plus 6. And then we want this value to be, to be 7 and 1/24. Or if we do 7 over 1, so we multiply 7 over 1 times 24 times 24 plus 1 over 24. 7 times 24 is 140 plus 28, so it's 168 over 24 plus 1 over 24, which is 169 over 24. Okay. All right. This is 2a equals. So we want this value, this is our function evaluated there. We want that to equal 7. We want this to equal 169 over 24. 169 over 24. Okay? So we distribute, we expand, so we have a times 25 over 4a squared plus, or excuse me, minus 25 over 2a plus 6 equals 169 over 24. So then we multiply a in, so we get 25a over 4a squared minus 25 over 2a plus 6 equals 169 over 24. We have an a on top here and an a on the bottom and two a's on the bottom, so a over a is going to go away. So now we want to find a way to get to combine like terms. So here we need to multiply this by 2 over 2. So we have 25 over 4a minus 50 over 4a plus 6. 25 minus 50 is negative 25 over 4a plus 6 equals 169 over 24. So if we subtract 6 from both sides, let's see, if we make 6 over 24, we say, let's see, 6 over 1 times 24 times 24. We're looking at 120 plus 24, so 144 over 24. Okay, so 144 over 24. So we're going to subtract 144 over 24 minus 144 over 24. We are left with 25 over 4a equals, let's see, 169 minus 144 leaves us with, is that 25? Yeah, 25 over 24. All right. So then from here, since we have a fraction equals a fraction, we can cross multiply. So 25 times 24 equals 25 times 4a. Whenever we have something multiplying on both sides, if we divide both sides by 25, this is going to go away, this is going to go away. So we have 24 equals 4a, and then divide both sides by 4, we get that 6 is a. So the long way to get to here is we said that a equals 6. So if we have this value as 6, then the minimum value of this graph is going to be the y value of this, the smallest y value this graph will get is 7 and 1/24, or 169 over 24. Okay. Again, I think that's a cool problem. I'm not going to be asking you about that, but it's I think interesting enough to look at and take some time to talk about. All right. That is it for the test review. It only took 3 parts, but we got there. We got there one time. So I will see you tomorrow. Feel free to study. Feel free to come and ask me questions. Hopefully these videos are pretty comprehensive, and I will talk to you tomorrow. Bye, guys.